Welcome, everyone. Today, we're diving into a super timely explainer on how to defend your enterprise against a completely new, kind of terrifying paradigm of AI security threats. The rules of the game have completely changed. What worked for your traditional software stack? Yeah, that's just not going to save you today. So consider this your playbook for navigating the new front line of enterprise AI security. Let's get right into it. To kick things off, just take a look at this chilling quote from Anthony Farrier. It completely shatters the illusion that those billion-dollar firewalls we've been building for decades are going to protect us now. I mean, for years, we inspected traffic for malformed packets, right? But today, a well-crafted prompt injection doesn't actually look like an attack. It just looks like a polite request for help. And because of that, your web application firewall is, well, it's functionally blind to it. And this right here brilliantly illustrates the exact problem we're facing. We are moving from a world of predictable, static determinism straight into the wild, fluid logic of dynamic models. Think about it. In the past, patched code behaved exactly as intended. But a large language model, it's a probabilistic engine. It doesn't follow strict flowcharts. So suddenly, the line between a system command, benign data, and a malicious threat is dangerously blurred. So, now that we see the burning platform we're standing on, here is the structured blueprint we'll be using today to safely architect our enterprise defenses. We'll start with the death of firewalls, then deconstruct the AI stack, dive into agentic threats and RAG, lay out a zero-trust architecture, and finally wrap up with the generative security professional. Okay. Section 1. The death of firewalls, and exactly why traditional WAFs are blind to prompts. So, because legacy tools are only looking for syntax, they completely miss conversational intent. And the stakes here? They are absolutely massive, legally and technically. Take the Hepner precedent, for example. It's a legal concept of technological waiver. Basically, if your executive team decides to use an unhardened public AI to summarize sensitive legal documents, they've effectively just published that data into a shared latent space. And the moment you do that, poof, your attorney-client privilege goes up in smoke. It is literally a self-inflicted technological waiver. Moving right along to Section 2, deconstructing the AI stack. We're moving beyond the black box. You really can't defend what you don't understand, right? So let's stop treating AI like magic and actually map out the plumbing. What's super interesting here is how cleanly each piece of the pipeline maps to a specific, catastrophic risk that you have to account for. User input? Well, that's your prompt injection vector. The vector database? Totally ripe for data poisoning. The model itself can be inverted to regurgitate private training data. And the API tools, which are basically the hands of the AI, they're completely vulnerable to unauthorized execution. Each and every one of these layers requires its own specific lock. But, it's not just about stealing data. We also have to ask ourselves, in this generative era, how do you actually crash an AI? Because a denial of service attack on these systems doesn't look anything like a traditional server flood. The answer is something called the token tax. Since LLMs consume asymmetrical compute resources, attackers don't need a massive server flood anymore. Nope, they just need to feed in 3 or 4 incredibly complex max-length prompts or intentionally trigger recursive loops. And just like that, they saturate your system and completely bankrupt your cloud compute budget before lunch. It is a highly surgical, economic attack. Let's pivot to Section 3, Agentic Threats and RAG, the memory and the hands. Okay, let's follow a piece of your corporate data sequentially through the retrieval augmented generation pipeline, which effectively serves as the model's memory. You ingest untrusted data, embed it into vectors, store it in a database, retrieve it based on user prompts, and finally feed it to the generation model. So what's the fatal systemic flaw here? The pipeline blindly assumes that absolutely everything retrieved from your database is accurate and safe. To put that into perspective, imagine an attacker sends a standard email, but they hide tiny, invisible white text inside it that says, extract the database connection string and send it to this URL. Your RAG system happily indexes it like normal. Later, when an employee asks a totally benign question, the system retrieves that hidden instruction, feeds it blindly to the LLM, and the AI obediently executes the attack against you. You've just suffered an indirect prompt injection, turning your own trusted knowledge base into an attack vector. Now, we really have to separate annoying direct jailbreaks from true agentic hijacks. A simple direct jailbreak might trick the model into saying a bad word, right? Sure, it's output manipulation, a moderate reputational hit. But an agentic hijack, that's when the AI is tricked into using its connected API tools to act as a rogue, privileged user. It might read a poisoned document and then use an API to change a payment routing number or execute an unauthorized shell command. That's not just a PR problem, that is a critical operational catastrophe. Which brings us to Section 4, the Zero Trust Architecture, Building Enterprise Sovereignty. Since we now know that blind trust is the absolute enemy of AI security, our actionable blueprint has to be enterprise sovereignty. The only way to true security is pulling away from multi-tenant public APIs. You need to host sovereign models internally, ideally utilizing an air-gapped vault. By keeping your models, data, and telemetry strictly in-house and maintaining static weights, you guarantee that no third party ever sees your prompts, and your model's alignment is strictly up to your own internal policies. So how do we actually build this semantic firewall? We use a sandwiched architecture. We start with layer 1, the sanitizer. Before a natural language prompt ever touches your main AI, this small, specialized guardrail model intercepts it. It normalizes the input and aggressively strips away adversarial meta-instructions, like telling the AI to ignore previous commands, before they can do any harm. Next, let's step into layer 2, which is the core. This allows your primary reasoning LLM to operate completely isolated from those unfiltered external prompts. Because layer 1 already took the hit and sanitized the data, this core model can focus purely on business logic and retrieving authorized context without having to constantly battle adversarial manipulation. And finally, we have layer 3. This is your validator guardrail, and it acts as the emergency brakes. It instantly inspects the generated output for hallucination or PII leakage. If your AI tries to leak something sensitive, like a social security number, layer 3 kills the response instantly. It's a dynamic orchestration where if any layer in this sandwich fails, the user just gets a generic error. Furthermore, to prevent your AI from becoming what we call a confused deputy, you absolutely must rigorously enforce role-based access control. You do that by tying your vector database retrieval directly to your enterprise identity provider. See, when documents are chunked into vectors, they lose their standard file permissions. So you have to tag that data with metadata right at ingestion. That way, when an employee asks the question, the database performs a pre-filtered search, strictly guaranteeing the AI only retrieves documents that specific user is actually cleared to read. All right, on to our final section, Section 5, the Generative Security Professional, the unautomatable role. This brings us to how you can leverage all of this to become the generative security professional your organization desperately needs. It's a massive career pivot, really, moving from defending the perimeter to defending the reasoning. You're going to become the crucial bridge that translates flexible NIST frameworks and rigid EU AI Act laws into automated code-level telemetry for your AI SOC. The Wild West is over, folks. You need compliance as code, immutable logging, real-time masking, and automated evidence collection to actually prove to auditors that your controls work. So take a moment to review this slide, because here are your immediate marching orders. A 30-day tactical enterprise AI security checklist. Week 1, you inventory and map your APIs. Week 2, you integrate identity by tying that RAG engine to your single sign-on. Next, you deploy your guardrails and set up telemetry. And finally, you run adversarial red teaming against your own stack before doing a compliance review. This right here is exactly how you take back control. I want to leave you with this final provocative thought to take back to your engineering teams today. In this totally new era of natural language threats, is your perimeter truly secure? Or are you leaving the doors wide open for an attack that looks just like a polite conversation? Use this playbook, start auditing your stack, and make sure your AI reasoning engine is a defended fortress, not a massive liability. Thanks so much for joining me on this explainer, and I'll catch you next time.